Hello, everyone, and welcome to the second Tech Espresso on behalf of XR Valley. Um, this is um, this is a new monthly moment of gathering the XR community in Belgium, specifically for people that are involved with tech and development. And in this webinar, we are diving into new technological advancements in the XR space, as you would have figured from the name probably. And not only the new tech, but also the opportunities and the challenges that come along with it. And the topic of today is how to navigate the challenges of XR product development, specifically new headsets and all the tech that goes into that. For this, we have two speakers lined up today. The first is Cedric Haverbeke, Managing Director of XR Valley, and he's going to take you a quick overview of the latest releases and the promises that they'll bring along. And then we have a keynote by Fabian Nappenbach on how to align technological ambitions with often the hard walls of reality. Fabian has 20 years of experience in selling and promoting high-tech marvels. So this is really the brain to pick during this espresso. And I'll leave the further introduction to himself at his keynote. If you have questions or remarks or anything you would like to share, you can drop them in the chat box next to your screen. And we will address these at the end of the keynote of Fabian, together with Fabian and Cedric, both of them. So I'm giving the floor to Cedric. Please enjoy this webinar.
Hello, Pia. Hello, everybody. Yes, so hello, everyone. I'm giving a short intro before we have Fabian with us. Goal is to really share my perspective. For those that don't know me, I'm Cedric. I'm the managing director of the XR Valley. But apart from doing the XR Valley, I'm also active in the XR space. And probably just like you, I'm trying to navigate all of these headsets coming out. Which ones do we am I actually going to buy? How do you make a selection? What should we know about what we should we know about the current selection? And to that extent, I'm just going to show a couple of slides that I always use to kind of illustrate how I look at it and what I find important. And then we have Fabian, who's going to deep dive on a specific on his specific headset. So just going to put something on my screen. There we go. Present. All right. So just as how I measure success in everything that is XR, it's the cost versus the reach versus engagement. Obviously, if you're going to buy a 25K what is it? The Gaia OpenBCI headset, then you're going to have a very high cost, and because of the setup time, you're going to have a hard time reaching a lot of people. But you might have a very high engagement for the person experiencing the headset. But this is what is important to me. How I also look at it is when we're doing XR content, there's four places basically. Well, yeah, there's four type of headsets, and there's three places where people actually experience XR. And this is how I look at it, in the sense that when you are location based in an experience center, a museum, a dedicated venue, there you have full control and you can go say it more elaborate on the type of hardware you're going to use. At work or at home, you might not be using the same type of equipment. You're going to go more to the prosumer tethered or all-in-one XR devices, or a consumer all-in-one XR device. And then of course there is still a smartphone-based XR, and that's a bit how I look at it on a high level. So when it comes to the maturity, slides are a little bit outdated, but the thing is that the consumer devices that now are on the market is, of course, the Apple Vision Pro, the Quest 3, with now the release of the Quest 3S, Those are a bit of the, how to say it, the wider net. And then you also have the Picos, of course, but those are the ones casting a wide net. Also the PlayStation 2 VR headset, those are all consumer. And then you have, of course, also the big screen Beyond, which is custom built. So those are a bit the headsets in that space. My impression at the moment is that it's especially the Quest 3 and the Quest 3S that have the most users. While that because of the PlayStation VR with a direct link, that it's also gaining momentum. But for me, what I'm really looking at is okay in a location-based VR setting. The ideal headset, according to me, follows this spec list. Why do I look at location-based VR? Because most of my customers are corporates, are organizations. I think from a content perspective, it's definitely interesting to make your content available for the at home market. But that is a pure platform play. There's little custom control. My focus is mostly working with brands to really deliver tailor-made experiences that explain their brand. So really in these dedicated venues, and that's why I look at it in this way. Um, I'm briefly going to go through the most important things that I take into account. The bottom line is the PC VR through Wi-Fi, the field of view, both horizontal as vertical, the resolution, the tracking space, that it's a 100 square meter tracking space. Those are all related to engagement because I feel that when you are doing XR experiences as for brands, it should be something that is exceeding what you can have at home. Just today, I think Batman, the new Batman title on the Quest came out, and apparently it's amazing. So that puts the benchmark of what people can experience at home for 300 euros. So that means that you have to be 10 times as good as that when doing the location based. So I think you need that PC VR power and all the rest. GDPR compliant is also important for me, and TAA region produced, that it's produced in a region so that it can be used for government contracts. And then for me, the nice to have are hand tracking capable, easy mobile device. And eye tracking is important to me. Why? Because of the foveated rendering that it allows, less from an input, less from an input perspective, but really from, again, because you want to have that as unlimited power as possible coming out of the headsets. So that's how I look at it. And quite frankly, where am I at now? Also making a couple of purchase decisions. I'm shifting between the Vive Focus 3 Vision and the Pico Ultra. They both have their pros and cons, but that's a bit where I'm, after looking at all the headsets, that where I'm landing on for at least the coming year, maybe 2 years, to be my go-to headset. So that's just the perspective from the buyer side. And now I leave the floor to Fabian to explain, to take us along in the Focus Vision 3, and why they made the decisions that they made on this headset. So that was me. Hello, Fabian.
Hey,
So Fabian, and also everybody, thank you for being here on the second Tech Espresso. You may know, Pia may have mentioned that we are exploring this platform. And Fabian, I don't know. I was just asking Fabian if you were able to catch part of what I've been saying or not, or if I should summarize it for you, because we were before in the back realizing that when you're in the back, you don't see what's happening up front.
yeah, I feel like I'm in a talk show backstage, and I don't know what's talking in front, but that doesn't matter. No worries. You got me the gist of it before, so don't worry. I'm good.
All right. So just I set the scene, and now take it away. I just presented that what I'm looking for ideally and open the floor for you to explain. Okay, tell us more about the 5-focus vision and why the decisions were made on that headset. And we have a good audience here. Then afterwards, it's Q&A for the both of us.
Excellent. Thanks, Cedric. Yeah, hi, everybody. Yeah, I'm not giving you the normal sales presentation of the headset because I understood that that's not what this audience is interested in. In fact, that is what I did the last 3 months. So I did probably 60 pitches of the headset. But now I want to give you more or less the making of, if you like. Let me just see if that worked. My job with HTC started in the year 2010. My journey with HTC started much earlier. So because I was a geek, I bought myself every gadget available, and that started with the first XDA. That was one of the original early on Windows mobile devices, which was also the first real smartphone from HTC. HTC started in '97 with notebooks and some PDAs, and then moved into the Windows PDAs, which were revolutionary. We called them PDA phones because smartphone, the term, wasn't really coined. And then started a lot of partnerships. I mean, our first partner were operators, then Google for the first Google phone, the Nexus 1. We kind of helped them build Android in a way. So the first Android prototypes were all on HTC phones, and parts of making it a usable smartphone platform was also done by us. And that was a common theme. So in our history, where we did a lot of partnering, even with Under Armour for smart scales. We once owned Beats, which is now owned by Apple, ironically. So again, doing a lot of collaboration there. And one of the decisive collaborations for today's sessions happened during around 2015, when we met with Valve, the software company from the same area where our US R&D was sitting, and we gathered together and created the first Vive, which was the first, I would say, true 6 degrees of freedom VR headsets. And ever since, that transformed the company from a smartphone vendor now to almost a pure play VR, XR hardware and software manufacturer. When we talk to customers, I always use as an industry, we as an industry are kind of guilty by over-promising, because that is a video we actually showed to our customers, I think around 2017, 2018 in Barcelona, to inspire people for the future. And I think the idea of what XR and AR should be looks pretty much like this. Small, fancy, sexy glasses, everything looking a bit like a prop of a science fiction movie. And sometimes even the same use case and application, but without the glasses, holographic, super slick, and invisible. And this is still the vision, and I think this is still what we all should work for, but we have to do a bit of expectation management. One thing that is really dominant what people realize is the form factor we all want short term before we have holograms is basically glasses. Again, this is a design study that we published a couple of years ago of our vision of how light VR glasses should look like. That was the early design prototype, which then ended up being the Vive Flow, one of our first really glasses type headsets. And you still see in this image and also in the next one that there is still a wire, which nobody really likes. People kind of accept it if they're technical interested, but I mean, it's there, it's in your face. I know that Apple really tried to hide it. They were always asking the journalists to kind of put the wire behind their back so that the people don't see it, because they also know that people don't really look at a headset that is tethered in any way. What people, of course, also want is a screen resolution that will make pixels invisible. And as handset vendors, we solved that a couple of years ago. The moment we reached display resolutions of 300 dpi or higher, what Apple called Retina, pixel were invisible. However, that's at arm's length, and everybody can do that at arm's length. Unfortunately, headsets are exact opposite. So the moment you put 300 dpi image in your face, you see all the pixels. And interestingly enough, every year, the level of aspiration, what people think the ideal resolution is also raised. When we started with our first generation headset, which was like 2K in total, people were saying, yeah, once we reach 4K, everything will be well. And that 4K turned into 8K. And now if I Google for what is the resolution for mobile screens that makes pixel invisible, people are quoting up to 12 or 16K. So that will never stop. To fool the eye is one of the biggest challenges. The other where aspiration meets reality is, of course, the field of view, where we always put a lot of effort in, because people don't want to look at a tube at a scuba perspective, as a narrow field of view would suggest. Of course, what you want to be seeing is everything around you. The human field of view is 200 degrees, and nobody is there. Some companies try to fake 200 degrees field of view, but that was very distorted and not the real deal. So in a way, we are in this phase of the classic how it started, how it's going meme. We have all the same common vision of the science fiction future, but in reality, a lot of VR use cases are glorified experiences to watch TV. In AR, it's not so much different. If I look at the most prominent AR type headsets today, what they have in common is comparably low resolution, all in the 2K-ish region, and really small and narrowed fields of view. I mean, even the best ones, if you do the right calculation, they reach around 50 degrees. It's interesting. Some vendors will quote the diagonal field of view, which is kind of a cheating, because the diagonal is not what's relevant. You need the horizontal field of view, where you have to challenge against the 200. What you also see, I believe, Cedric also talked a bit about some of the AR headsets. They are still very heavy and very expensive. The only ones that are not heavy are the something like the Nreal, because the Nreal outsourced all their heavy bits to the phone. And then there is the Meta Ray-Ban glasses, which I also own and love, but they nailed the form factor, the size, the weight, even the price, I would say. However, they have 0 degrees of field of view and 0 pixels because they don't have a screen yet. And we also look very interested in what Meta showed, I wouldn't say released, with the Orion headsets. I mean, they're coming closer with the field of view. Resolution, they say they will get there. At the moment, it's still pretty low. Weight, totally acceptable. However, when they say 2,000 euro a piece, I think they were cheating there. I don't think that that is the cost that those samples really had. That was probably the BOM cost, so the sum of all their parts. But if you would want to release exactly that technology now, it would even probably be higher, including service costs and reserve and the whole manufacturing.
I think I even heard up to 10. I think they said 10K. That was a production cost.
Yeah, 10K.
Yeah.
No, they said they made 10K, or they made 1,000 pieces, 10,000 euro each.
Yeah.
And honestly, I don't buy it. I don't think those. I think those were more expensive. When we did phone mock-ups, and those were just the housing, our internal cost was a couple of thousand euro, and those were just pieces of plastic and metal, but they were handmade, and that's what's driving the cost. So don't think that you could release this headset for 10,000 euro today. You will do. We will all get there, but again, I think they made a bit of a little cheat there. Every aspect of the headsets are, well, highly discussed. I mean, I just realized that even just small bits like the lenses have huge discussions. So there is a camp that says, oh, everything has to be pancake because that's the newer one. And I agree, pancake lenses are great for some use cases, but they're not dominating. So we're always in a situation where you have to make decisions, like in that case, between what is more important. Do I want the great sweet spot? Do I want the better chromatic aberration or size? Or do I accept relevant things like field of view or even brightness? when it comes to screens, those are probably the biggest cost driver. And just looking at what's out there at the moment, you see that the relation between price and resolution is actually progressive. It's not like a normal curve. It actually grows really steep when you want to reach the really high resolution. So we started with 2K. Most of the usual suspect consumer or all-in-one headsets are in the 3-ish area, 3 to 4. We currently reached 5K, but we are already significantly more expensive than some of the 4K devices for different reasons. It's not just the screen. But then if you want to go higher than the 5K that we know going, you can double and triple the price of the headset very easily, as we see with the Varios and Apples. So we kind of try to catch a middle ground here, which means we make two people angry, the people that are just looking for price and the people that are looking for the best resolution. But then in the other hand, it could be a good compromise. The other component that's, of course, a bottleneck is compute power. There's a lot of really good development in systems on a chip. I think Apple really was also driving Qualcomm to produce really good shit. Qualcomm did their yearly updates, but they were really incremental. And then when Apple set the world on fire with the M series, that improved. So if we look at the most common chips now, just the processing power for the GPU, if you use a teraflop, they're in the 3 teraflop area, which is fine, which already gives you some good mobile applications, but it doesn't give you anything that's photorealistic or can compete with any game console, etc. So what we actually say is the minimum for PCVR. We say something like an RTX 2070 graphic cards would be the minimum. That's already more than twice as fast than the best of the best mobile chips. However, if you want to go photorealistic, if you want to use Unreal 5 with all the bells and whistles in 5K or going forward 8K or whatnot resolution with the 90 hertz or 120 hertz refresh rates, you better get some of the big boys from NVIDIA with the 50 or even more teraflops. Problem is that I don't think this image is still to scale. I tried to make it a bit to scale, but the size difference between a graphic card and a mobile chip is enormous. And I didn't even start talking battery consumption. I don't have a depressing slide on battery, but of course, that's one of the other bottlenecks. The big hope for the industry is that the cloud will fix it. And yes, I think the cloud fixes a lot of that. The cloud fixes the constraints on size, because a 5G antenna module is relatively small. You can fit that into any headsets. And also the power consumption of a big SGPU compared to just the streaming capability is negligible. However, the cost is still the same. It doesn't really matter if you just stack up those graphic cards you own, or if you ask any of the cloud players, AWS, Azure, etc., because what they have to do is not only buy those super expensive GPU and reserve one for every user, they also have to multiply that and be local. So all those data centers really only work for cloud VR if they are close to your actual users, because otherwise you add so much latency just through the physics of the length of the data travel. So before I start getting too depressing, so how do we handle this? What is the recipe? How do we get through all those bottlenecks, which actually makes the job more interesting? Everybody can say, I just buy the best components that are in the market. Problem is, then you end up with a 10,000 euro headset, and everybody can price optimize the hell out of it and end up something that's crap. So the origin story of our current headset, the first thing that my colleagues were obviously doing is fixing a budget, which is not trivial, because you have to serve different customer groups. If you just address dads that want a Christmas gift, they probably say 300 euro is a good price, and businesses probably have a budget up to 2,000-3,000 euro. And we are also competing with people that are not calculating like we do. We calculate very old school. We take the cost of device and we add a little margin, and that's the price, like any other business. However, Metro, for example, has this little social network side hustle, which is subsidizing their headsets, and that's why their prices look way different. Then we have to make all those little decisions, for example, on the visual stack. I quoted lenses as an example, screens, processors, all those classic bits where there's always a choice between waiting a bit for the next generation, taking what's in the market, taking the most expensive one that's hardly available to something that's proven, and also decide on who's this headset for. Is it for standalone gamers? Is it for businesses with a big data center? Is it for the cloud? Speaking of the cloud, we kind of did some effort and use it more wisely than just throwing money at it. And then there is something that are called the not so sexy topics that are also very relevant for business headsets. So to give you some examples, and a very popular topic of the lenses, our current decisions where we use pancake lenses on our glasses headsets, and we use Fresnel lenses on our headset, big form factor headsets. Why is that? The glasses is something where size really matters of the components. So that's where a big benefit of pancake goes in. And also these are use cases that are probably more like watching videos or watching story-orientated games, where the sweet spot is very relevant, not so much the field of view, whilst simulations like business applications where people have to walk around and feel real, that's where field of view is really the dominating factor, hence our choice for Fresnel lenses for that respect. Another thing that I mentioned is who's doing the rendering these days. So we most of the time sell to customers who still use the PC for rendering. The headsets are standalone. They have their own internal processor, but most of the time that is only in charge of input-output, and people really use some sort of PC streaming. But then again, not all PC streaming is created equal. So in our case, we now added DisplayPort, so we can have native PCVR. That means instead of taking your brilliant RTX 4080 image and then crunching it together into a video stream, we just take the direct output of the graphic card, which means we can power the headset through the cable, we can crank up the refresh rate to 120 hertz, and we also don't have any limitations on fidelity. There's no compression, there's no loss of latency whatsoever. On the clouds, yes, we work with cloud providers. There's also options to connect 5G models to a headset and use the classic cloud from NVIDIA. However, we developed something that we call polygon streaming, which tries to solve this equation for many use cases. So instead of having to have one GPU for every user, we stream multiple users through less GPUs by a process where the actual 3D assets are not sent fully, but they are streamed one after each other. So there's a little LOD and also some clever occlusion mechanics that any pixel that is not really visible doesn't need to get streamed, and some other tricks happening in the background, which in essence enables us to show 3D objects with millions of polygons on low-tier hardware. So you don't need 6G connection for that. You don't need a PC. It runs on phones. It runs on small, underpowered other hardware, and still you can have photorealistic graphics. So that is some of the things that we do until somebody cracks the nut of endless compute power in your palm. The not-so-sexy bits are a lot of mechanics. If you talk to gamers and look at what they are using and then compare it to office PCs, I think that's a good example. I mean, I can get a keyboard for 20 euros in the supermarket, and that has all the keys. Or I take a gaming keyboard that costs 200 euro because the mechanic is so awesome. And the same is true for headsets. Ours are mostly built for endurance and also for quick turnaround time, which is something that is super relevant for businesses. Consumers wouldn't need to care so much. So that's why we use magnesium instead of plastic. We made all the parts replaceable, washable, and optimize the time people get in and out of the headset, which is all great. However, it adds a lot of costs. Mechanics are relevant. Mechanics are very hard to scale. Those are very expensive parts. But it gives you other benefits, like the batteries can be hot swapped, which is really nice for somebody who wants to use them 24/7. Instead of charging them, just swap out the battery and stack them up. And of course, the rest of the homework was building for mixed reality, which at the moment is state of the game, adding cameras, adding LiDAR sensors for mesh environments, but also looking into things like, can hand tracking be better? Hand tracking is something, well, we and our competitors use for a couple of years, and our software guys are, optimizing it all the time on the algorithm side. However, then there is things like, oh, it's dark, hand tracking falls flat because those camera can't see shit. That's why we added an infrared floodlight to the headset, so an invisible extra light that just shines on your hands and makes them visible only to the camera, so the hand tracking is improved. Those are those little incremental upgrades that are most of the time very business oriented, because we work with a lot of people that build, for example, museums, etc., where you can't have perfect lighting, but you still want hand tracking, and that's why optimizations like this are very relevant. Another thing we added that we once kind of innovated, the Vive Pro, I think was the first mass market headset to have eye tracking. It was always an extra or just possible with very expensive headsets. We now put it in as a standard because, again, it gives us a lot of things to play with. Some app developers use it now in training simulations for debriefings. For example, we sell to a lot of people that do police training, and they're using eye tracking. You can then debrief and say, oh, did you look in that corner? I see you didn't, because I have the records of your eye tracking. It also helps for GPU power because you can do foveated rendering, so only fully render the bits where the eyes are actually looking. But it also adds practical uses like automatically adjusting the lenses, again, making the turnaround time between users faster. And finally, our main customer group at the moment are multiplayer scenarios, which in business is very relevant and which a lot of the competition is only starting to look into. Some of them don't do at all. And this is very relevant. So I copied this little image there from the IKEA manual. A lot of real life jobs are not single player. This example is a police force. A policeman never go out alone. Normally there's a pair of policemen, or this example is a police force of Mexico. So they probably have to round up some drug dealers. And so they come in force. And they use VR for real life training. And we did a lot of effort for the platform for that. We call it the location-based software suite, which is a bit of a mouthful, but in essence is increasing the play space to 1,000 square meters, so you can have a full gym running around, not worrying about walls or looking into silly stuff like treadmills, but really just walking like you would normally do, with all sorts of different tracking modes for normal environments, for simulators, for mixtures. So I think our main business driver at the moment is those multi-user scenarios. You can use that to train police, military, firemen, but the same technology is also relevant, let's say, for a healthcare scenario where you want to train doctors running around an emergency room. Again, whenever you have a big coordinated group of people that want to train on the job, that is where this technology really shines. And last slide, it also helped us to achieve this. Sorry for the really stupid joke, but we are not just doing spatial computing, we're doing computing in space. we managed to get a deal with ESA and NASA. And the current Focus 3, which is the predecessor of the Focus Vision, is the only headset used on the ISS. And again, that is not trivial because tracking normally doesn't work in 0G. All the gyroscopes, all those sensors are normally totally confused in that environment. So we had to fix that. And what they're using it for is mental health, another great topic for VR. For VR, so when people there sit on the space station and are really bored, they can virtually go home to, in that case, I think it's Norway, do some training and work against this homesickness that you get in space. Very relevant these days because there are some astronauts who plan to be there for 8 days, and that turned out to be 8 months. So we didn't know that, but that is also one of the aspects. So that's it. That's kind of the thinking behind our current headset, which you see here in all glory. And I will stop presenting now, so I see you back again. So for the next bit, which I think is a Q&A part. Right, let me see if I pressed all the right buttons and you're still here. Yeah.
All right, great stuff, Fabian. Thank you very much. Very insightful because I had a couple of questions prepared, which you already answered, which is always good. Because one of the things that I, of course, wondered about was why did you do Pancake versus Fresnel, which you very clearly already addressed. So I have a couple of follow-up questions. I think in the meanwhile, I definitely want to also invite the audience to come up with a couple of questions if they have any. I already had people WhatsApping me that it was really interesting. So you did great. It's not just me, Fabian. So our questions. Let me see here. Hand tracking. You answered. Room setup. You answered to a certain extent. The suite, the LBE suite that you have of easily setting up the mapping models and everything. But drift is something that I want to talk about because I remember back in the days when I was CTO at the park, a location-based VR setup. We were using the OptiTrack, and then we switched to Steam VR lighthouse tracking to prevent drift. But now and then we weren't doing inside-out tracking because there was still drift. For those who are not familiar with drift, it's basically because the headset purely relies on its cameras to know where it is. That if you would walk a 100-meter straight line, it wouldn't necessarily be exactly it would be drifting, that the headset would think it to be, for example, still on the straight line, while if you actually look at it, you would be a meter to the left or a meter to the right. And what we noticed is that now with mixed reality coming up, it's a lot more visible. It's a lot more visible that if you are putting a virtual object in your space, that it might drift compared to the real world. So do you have any insights on drift? How you guys are doing it?
Actually, drift is a big rabbit hole because it also depends on the environment. So there's different ways to do it. Actually, we had a cooperation with a startup that managed to put VR in the car. Maybe the market was not ripe for it, but the drift prevention was the biggest effort. There was a company called HoloRide in Germany.
Jonathan.
Pardon?
Isn't it Jonathan? The guy behind it?
Anyway,
sorry.
But they're like only spin-off. And so for them, drift was the worst because you were sitting somewhere with a visual tracking system on something that was moving all the time. So their drift was done by drift correction was done by using the cameras and maybe trying to figure out parts of the car that were not moving. So they were kind of adjusting it to the car windows, which was kind of like a static point. But that was like really a quick workaround without having a lot to play with. In terms of our solution that we did for the ISS, they actually use one of the controllers and fix them at some point at the space station and use it like a North Pole. So there's like the North Star that is like a relative position where it goes back to. which works but has a disadvantage that this only works on small range. For the big LBSS installations, the go-to solution is Aruco markers. So there is these, they look like QR codes. They are like whatever, a normal paper-sized visual marker that is configured in our software, and you place at least 2 of them in the room, and the camera will pick them up and find their relative position and readjust it all the time, because those solutions, not just drift, but also really the position of all the players relative to each other is very relevant. Otherwise, people keep getting walking into each other. So for the moment, I think Aruco markers is something that has been there in the industry before, but we really hardcore integrated it into our LBSS software, and it's the go-to solution for LBSS now that use standalone headsets with us.
Okay, so it's that was going to be my next question, because I for a second I thought that it meant that everybody that now will be developing mixed reality applications also will have to spend X amount of their development budget on just fixing drifts for their specific application. But what I'm hearing is that in your solution, it's kind of when you have the LBSS.
Yeah, don't get me started.
Okay.
LBSS, application-based
Okay.
software and services. Yeah.
When
We're
you have
terrible
the
on naming. Don't record this, but we're terrible on naming.
So, but on the LBSS, then, if I understand it correctly, you get the LBSS, and then you get basically print files, and the Vive Focus 3 and the Vision would recognize those markers just if you put them up.
Yeah.
And it's also okay.
Yeah,
So
that's part of the whole map sharing solution that's inbuilt into that platform.
Okay, so actually, what I'm hearing is that yeah, because now I recall, for example, if you have a multiplayer with 5 players and they are all using their own coordinate system, then it's very hard to make sure that they are speaking the same coordinate system. So you have to anchor them. All right. Okay. Okay. So that's on Drift. Yeah. Market size was another question that I had. I mean, obviously, I don't want you to say, okay, this is how many headsets we have in the market. But I think, yeah, do you have a feeling with how many consumer headsets are out there? So the target audience, the target market people headsets at home, and then how many headsets are there in corporates? And how many headsets are there in LBEs? If you would have to put a number, so 3 numbers.
Yeah, okay. Let me try 3 guesstimates that are kind of nearing there. So the total number of gaming headsets is, of course, not known because nobody shares, including us. You can get some info by digging into Steam numbers. If you go in there, you see that active users of VR headsets is around about 3% of the installed base of the users of Steam, and go from there, which translates in a couple of millions, I would say, that are really active users. I mean, like with all those technologies, some people buy stuff and then put it in a drawer after half a year. I think that's where all the GoPros sit now. But here, those are really recurring active users. And I think Meta also used numbers like this. Users in LBE, LBSS, that's quite a big number. I only know one anecdotal number from one of our partners, which is HoloGate in Munich. So they are similar to the Park. They started with arcades, now do a lot of business. And they all, up to date, counted 20 million customers that they served. There might be double counting in that, but it's still, that's just one of many of those players. The Park is another one. EVA, who does a lot of sports, is one. And so those are not headsets. Those are really people that experience VR, which I believe is very important, because I think we are still at a very early stage. Like with video games, when I was a kid, I couldn't play video games at home because not even Atari was invented when I was a really small kid, but arcades were there. So that was the first stage. And I think something similar is now happening with consumer VR, that those arcades are really helping educating people about it. business, that's I think that's the hidden gem. I think people don't realize that VR in business is quite relevant nowadays. I can't tell you numbers, but industries that are picking it up, um, the military industry or the whole training sector for that is quite relevant, and that's the one where we are very popular because those people really don't want to buy from China or from a social network. So we have like an almost immediate insight there. And so that doesn't mean we are producing weapon. We actually help them development, but we also help them training people. And I think a well-trained policeman and a well-trained soldier actually saves lives. So I'm a very pacifistic person, but I'm still okay with that. And then the initial big industry was car manufacturing, which used them in the design process, but also for visualizations at the shop floor. So, for example, Porsche of all people is one of our customers that use this for pop-up stores where they go into huge malls, put their one dummy Porsche in, but then have a great simulation where you can change everything down to the color of the leather stitching and display it like that. So that is, again, one of the bigger industries. In general speaking, training so far seems to be the most relevant use case. There's communication, there's all sorts of other things, but the beauty of training is that the return on investment for the customer is pretty easy, because you normally train something in VR that's either very expensive or dangerous. So instead of building a fake shop floor or building a fake big machinery in Airbus, you just do it in VR. So the costs are ridiculous compared to what you're replacing. And that's why that is a easier job for us to convince those people. Those are the most innovative ones. But it's still early stage. There's so many industries that I believe would benefit from it, but where we only slowly getting into, or need guys like you to help us to do all the convincing and evangelizing the technology.
Yeah. I mean, to add to that, just to jump on it, to also add a little bit of my side, is that I'm also hearing that around 80% at the moment of headsets sold are being used in training. So there's definitely, I mean, on our side, I mean, me personally, we work indeed a lot with culture, arts, entertainment, and the other parts. But that you also see it with a lot of the ISVs. Sorry, with a lot of the software products. There's a lot of training products out there. The other markets are still very early. Maybe one thing, one of the topics that we were discussing with our healthcare committees. There was a recent article in Time magazine that I forgot the name, but a specific surgeon was testing with the Apple Vision Pro in the surgery room at controlled environment. Do you see some adoption? Do you see some do you have some technical insights? Because we're not here to talk about business adoption too much. The question that I had about market size was mostly about as builders, where is your opportunity to build for, so that you have return on your that you're building
We
for the right
actually have
industry.
we actually have several of those healthcare lighthouse projects. For example, with one American clinic they're training freaking brain surgeons in VR, but they're giving them the base movement training with the normal tracking. The moment you want to train surgeons, you need something that is more precise than any hand tracking can do. So most of the time, those people use something like a mixture. So they have a little robotic arm with a fake scalpel that has sensors that then gets mixed with the visual that the VR is providing. Because hand tracking is the most unprecise thing. So if you take an Apple Vision Pro, etc., you can train how to look at a brain but not touch it. So that's where you need advanced tracking hardware. We also supply those ultimate trackers that you can put to things like, I did a simulation where you were doing like a hip transplantation. So you were having a heavy instrument to really, it was brutal, hammer into the hip bone. And that was equipped with our trackers. So for tasks like this, VR tracking is definitely good enough now with those advanced trackers. But you, first of all, you need to support them. Not many headsets have them. And second of all, the use case has to fit. Otherwise, you're down to building something yourself, which some of the healthcare industry are doing.
Okay, so we're nearing the end of the webinar. So I'm going to ask one final question, as I think there's no question from the audience, but everybody's still here. So we're asking good questions and providing good content, so that's great. Um, uh, my last question would be a look forward. Like, I mean, I dare to say that the focus tree vision it's not a recycle of the focus tree. I think it's definitely an upgrade. It's really a product that learned a lot about the focus tree and is now doubling down on what worked. But I wouldn't say that. I think what I'm wondering about is the product leaps, to put it like that. In the same way that, for example, when we look at Apple, there's the first Apple Vision Pro. Reason to believe that there might be an Apple Air or whatever you would call it, and there's going to be another one. Meta is working probably on the Quest 2. Those are real product leaps, to put it like that. I'm not asking what is the next product leap for HCC, but what do you think? Like, let's have a look at. I guess we're more or less settling on 2 to 3 year cycles. So let's have a look at 26 and maybe at 28, what we could expect on those terms. I think, in the future we can expect Orion and whatever that we want, but on 26 and 28, what would be your perspective on where these let's also hone in on the location-based VR devices and then on the consumer devices.
Yeah. I mean, you touched the right point there. So the Focus Vision is not called the Focus 4 for a reason, because it's a midlife refresh. So it takes some of the existing parts and adds others to that. And so that's always as I said, the product manager's dilemma. Do you wait for something or release what you can release now? So obviously, there's the usual upgrade cycles that are very much triggered by the processors. The current processor upgrade cycle did not add dramatic upgrades. So that's something that we're almost skipping and waiting for something after that. And then, of course, there is a point that we're trying to hit where we can have significantly better images without breaking the bank. So what Apple did is throw money at it and took the most awesome screen that there is, but the result is a price point that we can't seriously use for mass market. So I think nobody has the range to sell 4,000 euro headsets in big spending. So the dream commercial headset, if you would like to say, is something like, take the best bits, the best innovations of Apple Vision Pro, but put it in a real headset at a real price point that has a lot of business optimizations, that uses real controllers, which are significant need. Hand tracking is not the solution. Eye tracking is not the solution either. A lot of things have to be really good tracked. And build something in today's price point with this kind of spec highlight features that you see here. How long that takes, I'm not allowed to quote, and when exactly. Those are all the forbidden answers. But I think that's the aspiration.
Yeah, I think you presented an interesting way to kind of predict the future. A way to predict the future would be look at the headsets that are literally $2,000-$3,000 more today, and bringing that to the commercial price points.
Maybe not all of it. I don't think that everybody will ever do this outside screen again, to be honest. Sorry for that. But other parts of it are, of course, impressive and well done.
Yeah. Okay. No, okay. Great. I mean, Fabian, thank you very much for all of your insights. I learned a lot, and thank you also for being one of our first speakers on the Tech Espressos. This is exactly what we want to achieve with these type of things. Just straightforward, being able to ask questions, open conversation from one XR believer to doer. It's not about believing anymore; it's about doing, and we're building industry momentum. So thank you very much.
Thank you for the opportunity.
All right. Great. Well, we'll be in touch. I mean, let us know when you are actually in the XR Valley, and then we're also happy to show you around on what everybody is building.
Cool. Thank you. See you guys.
All right. Bye bye. And thank you to all the viewers. Tune in for the next one. It's going to be in November, where I think it's on the website already. Can I already say it? Let me double check. Fabian, you're also welcome to be in the audience the next time. The next Tech Espresso is to be announced, but I can say it already. It's going to be more about content creation. We're going to be looking at meta-humans. Well, meta-humans, realistic avatars. It's like there's clearly this thing happening where avatars combined with Gen AI can mean something for XR applications. Because it's one thing to create a world, we're good in creating worlds, but if you can massively reduce avatars running around in your world, contributing to that universe, there's something there. And we want to explore, like, okay, where is the technology at when it comes to avatar or meta-human creation? Voila. So thank you, everybody. And enjoy the rest of your evening. And Fabian, thank you once again.
Bye.
Ciao. And as we are still testing out our platform, I don't have a stop button, and I just